Hi, I'm Alexis and I'm an inventor, and my latest invention is a tooth flossing device that should do the flossing for all your teeth in less than 10 seconds. And I'm about to test my next prototype. Hey everyone, I'm working on my next invention. I call it the tooth jet. The idea is flossing in 10 seconds or less. I have 3D printed this mouthpiece that should exactly match the gaps between my teeth. So there are many little pipes, as you might see here, and each of these little outlets will clean the space between my teeth. I just need to finalize the assembly and run the test, and so you can see that test. But the thing is, this is just the mouthpiece, right? Oh, it fits in more or less. I mean, it's the first prototype, we have to work on that. But I need a way to push water in. And I also have down here a vacuum system that will suck out the excess water so that it doesn't flood your mouth. So I need vacuum and I need water, and I have a whole box. That's the box here for all these auxiliaries. So step one is to do the whole assembly of that. See this hole? I see I've missed something. This one needs to go through here. I had the first version of this and I realized the hole is too small. That's the second version, but somehow I forgot the hole is too small. Now it should be big enough. Let's check. Yeah, that's gonna work. So, this is the housing for all the electronics. So I need to put all the electronics in here. I had it all assembled in the first version, and then I placed it on an inclined surface on top of a suitcase, and it all dropped to the ground and was destroyed, so I needed to reprint everything. But in the meantime, it gave me the opportunity to adjust a few things and make them better, but I need to find all my parts in my mess. I had a switch somewhere. Ah, here's the switch. I need to make that hole also slightly bigger, but for a first test it will do. Ah, here they are. These two, they come here. Let me give you an overview of what we have here. So we have an electronic control box. This is controlling this blower here that will generate the vacuum. And this one is a DC motor controller for this pump. And then here I have these two knobs. One will be for the water and one will be for the vacuum. So that's the whole setup here. And that most of it goes into that box. I think I'm screwed because I don't have the right screws. This one goes down here. I had planned to use countersunk M4 screws, but these are the longest one I have, and they should be about 5 millimeters longer. Let me check again. So that's M4 countersunk in my stash, but that's the longest I have. Looks like for now we will just do it with M3 and hope they don't fall through the hole. But it's not falling through the hole, that's already good. It's a good start. So, now, on top of this comes a cover, which is still in the printer. That's the cover we need. Plop, plop, plop. Now, Drum roll, will it fit? Good. So next I need to do the droplet separator. That's the thing I've built, where I come in up here with the air and with the air coming out of the blower, and I just want to make sure that the last few droplets are separated. So I go all this way down, and at each edge here there is a sharp turn that should catch the water and should then guide it down here, and it should all come out here. But the problem I had, I crashed the last one, so you see that one is broken here. So that's why I needed to reprint it. And now here I have all the screws and stuff in it, so I need to take them out of there and put them back here. Let's start with this connector first. Everything is inside the box now. All the electronics are in here and up in here. Now I need to connect the output of the cyclone to the input of my droplet separator. So that part is good. Now we have the second tube back here. So this is the freshwater tank, which goes through the pump and should come out here. Actually, here in the front I even have a nice channel to guide the hose where I want it. Okay, this one is the outlet to get rid of the dirty water at the end. Zack. So, now let's start with the pump. Ah, yeah, now it has primed properly. Yeah, we can pump some water for sure. That works. And the other one is the vacuum. This is the side where it is supposed to suck. And down here is the hose that goes on this. That it works. Okay, so these are the two hoses. Little thing. So, and that should be the final system. Yeah, no, far from being final, but that's the first prototype. Now, how do we test that? This is a 3D printed part. By definition, 3D printed parts are not perfectly water or airtight, and I haven't treated it with any sealant, so I'm curious to see if I send in some water, how the water will come off. It will come out through all the cracks, or if it will come out through the little holes. And I want to be down in the bucket to not make too much of a mess. So in the end, water goes everywhere except where I want it. These few jets look nice. These are already not doing what they should. That is full speed. It's not convincing. Definitely not convincing yet. That's all the pump can bring. I have to find a way to seal it to make sure water comes only out through the holes. But at least the whole pump and stuff works as it should. Now to the second part of that device we want to test today, the vacuum part. Put the water still in here. Maybe I should make these whole hoses a bit thinner, but so we will try to suck out water with the vacuum from here. Turn on the vacuum first. You see how the cyclone does its job by separating water and air. And actually, I'm pretty happy at these results because it separated the water in here, And the air outlet is here, right? So we have these holes down here where the air is coming out. And I had my hand in front of it, and you see it's completely dry. So I'm very happy about this, because that means separating the water out of the airflow works. And that works pretty well. Let's do a second test again, just to make sure. If we run it at full speed on the blower. Oh, you see how it's interesting. We have a leak down here. We are sucking in air, and yeah, but we have to check for leaks. Now it's time to figure out how much stuff I broke and where is all that water coming from. I mean, I had a leak from the water tank where because I moved the water tank. Since the tube is stuck on here, and I moved it a bit like this, and that led to that big leak. Maybe we should turn off the power going to that machine. And yeah, time for some cleanup here. Let's try to get rid of that water. Now, down here, we should be able to empty that guy by taking that one off. Yeah.
2,000 years later.
I might want to take a bigger outlet here to empty so it goes faster. Oh yeah, and we have also the water tank up here still has water in it. So let's pump that out using our pump. Turn on the water pump, and then we can empty out this one. Everything is empty and can be left to dry. So, to the conclusion. First prototypes always fail. That's a rule of nature. The 3D printing is definitely not waterproof enough. I have to figure that out. But for the whole design of that mouthpiece, I had a better idea on how to better design it in CAD to make it easier to generate. So I will have to completely redesign that one for sure. Emptying out the dirty water takes too long. That's not an option, but the cyclone works very well and the droplet separation works very well. I'm very happy about that part. The electronics work. So yeah, it's a partial success and we'll improve in the next generation. Thanks for watching.